In this session, we're going to discuss another method in defining or determining a root of a certain equation. So the name um, of that algorithm is fixed point iteration. So in fixed point iteration, okay, so definitely our equation, if we want to find the root of a certain equation, it should be equivalent to 0. So function r at r is equivalent to 0. So using this equation, we're going to rewrite it as function at r. Okay, so it's a derivative of this function at r. Okay, so when we rewrite this, it will be function at r equal to r. And this function is basically derivative of this function. So what do I mean by derivative? So it's a rewritten equation based on the original equation to solve a certain variable. So for example, we have this equation. Function at x equal to x cubed plus x minus 1. We're going to rewrite this equation to solve x. So if they rewrite, you're going to isolate one term to the left side, which represent the variable. Okay, and then on the right side, probably on the right side, that will be the equation equivalent to that variable. So if we're going to rewrite this, it could be rewritten as x is equal to 1 minus x cubed. Am I right? So we're going to transpose. So since f at x is equal to 0, so 0 equals to x cubed plus x minus 1. So you transpose x cubed minus 1 to the other side. So we have 1 minus x cubed. So that's one derivative of this equation. Another will be, okay, so transpose x minus 1 on the other side and cube root of it to get this equation. Or add terms to have this equation. Okay, so in root finding using iterative fixed point iterative method, you could add equations, add terms rather, to our original equation. Okay, but don't forget, and when you add terms, it should be equivalent, still equivalent to its original, okay, original equation. Okay, so later I'm going to discuss how we get this equation. Okay, so after rewriting our equation to this derivative, okay, so we're going to guess a value of x. So it's up to you what value of x, the initial value of x that you want to use, and substitute it to our equation. Okay, so given x0, so you guess, we have the equation, so solve, and then check again if the error is below or equal to the acceptable error. If not, so you're going to substitute the new x to our equation and then solve again for the error, and then you repeat this until you get the desired error. Okay, so let's go back to this equation, x cubed plus x minus 1. So let's look for the root of x. Determine the value of x. Okay, so we have three equations: 1 minus x cubed, cube root of 1 minus x, and 1 plus 2x cubed all over 1 plus 3x squared. Okay, so let's solve x cubed plus x minus 1 using this equation first. Okay, so what will be our first value? So I'm going to use 0. Okay, so 1 minus 0 cubed is 1. So itong 1 na to will be substitute to our equation to get the next x. So 1 minus 1 cubed is 0. Substitute it again. So 0. So if this is our answer, okay, it means our equation doesn't work to get the root of our original equation. So we need to look for a new derivative of the original equation. Okay, so let's move on with our second equation, okay, based on the original equation. So cube root of 1 minus x. So original values, or the first value, guess value, okay, for me it's 0. So the result is 1. Cube root of 1 minus 0 is 1. Substitute it here. What is the result? 0. Am I right? 1 minus 1 is 0. Cube root of 0 is 0. Then substitute it again here. Result is 1. So as you can see here, it's the same, not almost. It's the same with our first equation. It doesn't give us the root of x. Okay, so it means this equation doesn't work. So now let's move on with our third equation, this equation. But how did we come up with this equation? So by introducing two terms, okay, by introducing 2x cubed minus 2x cubed. We all know that these two terms, when we evaluate it, it is equivalent to 0. So therefore, it's still equivalent to x cubed plus x minus 1. Okay, so how do we derive this equation from this equation? So basically, we need to transpose first x cubed plus 2x cubed and x to the left side. Okay, on the other side rather, and then factor out x to get 1 plus 3x squared. Okay, and then that will be your denominator. Okay, so using this equation, same initial value, 0. Okay, so the result is 1. So 1 plus 2 times 0 cubed all over 1 plus 3 times 0 squared. It's 1 over 1, so we have 1. Substitute it here. So we have 1 plus 2 times 1 cubed all over 1 plus 3 times 1 squared. So the result is this. And then substitute it to our equation. And this is the new equation, the new x. Then continue this until you get the desired error. So by the way, the desired error here is 0.01%. Okay, so if you're going to compare it to the first two equations, third equation works. Okay, as you can see here, x is converging to a certain value. So our answer, since this is the one that less than or equal to the desired error, so after fifth iteration, okay, so we have 0.682327804 as our answer, as the root of x, one of the root of x. Okay, so now let's have another example. So let's have x to the fourth minus x minus 10 is equal to 0. Okay, so again, we need to rewrite it, okay, to solve x. So it could be rewritten as x is equal to 10 all over x cubed minus 1, or x is equal to x plus 10 square root of x plus 10 all over x. Okay, so in this example, in this equation, we transfer x4 to the other side. And then on the third equation, so basically we isolate the x to the fourth on the other side, and then cube root, um, you raise one fourth to each side. Okay, so this will be our equation now. So let's use this first derivative of this first equation from the original equation rather. So we have 10 all over x cubed minus 1. So what will be our initial value? So for me, again, it's 0. So when you substitute it here to our equation, then all over 0 cubed minus 1. So the answer should be negative 10. Am I right? Because 0 minus 1 is negative 1. 10 divided by negative 1 is negative 10. then substitute it to our equation. We have this, substitute it, have this. And what can you say about this solution? Same as with our first example, the first two equation in our first example, it doesn't converge to a certain value. So it's just going back from 0 to 10, 0, 10, 0, 10, 0, 10, or near negative 10. So this equation doesn't work. So let's try the second equation that we derived from the original equation. So we have x plus 10, 1 raised to 1 half all over x. So let's start with 0. Okay, so we don't have a formula here. So 0 plus 10 raised to 1 half all over x. So 0 cannot be used since it's divided by 0. So palitan natin, gawin natin 1. So we have 3.31. Substitute it to our equation. We have this. Substitute it again. This. As you can see, unlike sa first equation natin, dito merong malaking pagbabago even though it go nagka-alternate yung 1, 3, 1, 3, 1, 3, but on the decimal part, there is a significant change. So just continue it. Probably tama na to. Okay. Yeah. So as you can see here, even though na nagaan sa palipat pa 1, 3, 1, 3, 1, 3, but the value nagma-merge siya between these two values, the 1 and 3. Okay, so let's continue and solving. Okay, hindi pa siya. How? What can you say about the solution? From 1, 6 to, so they are merging, but the problem here is too long. The solution is too long. It's merging around the value of 1.8. Still not yet finished. So still continue. As you can see, it's merging. Okay, so still not yet. Okay, after 116 or so not after, it's in 116 iteration to have this 0.01%. So this is our root 1.855. Yeah, this equation works, but unfortunately, the converging in determining the root of x is too slow. Okay, but even though we get the root of x, the only problem again, the solution is too slow if we're going to use this equation. So let's try the third equation derived from the original equation. Probably this is better compared with the second equation. Okay, so let's start with 1. Okay, so 1 plus 10 raised to the 1/4. So result is 1.82. Substitute it to our equation. We have 1.85. Then just continue substitute if we have new x. Okay, and after or in the fourth iteration, we got 0% error. Okay, or less than 0.00. Okay, less than 0.01 error. So therefore, on this phase of our solution, we stop. So if we're going to compare this equation to this equation, this is better. Okay, this is better since we only have 4 steps. Okay, in determining the root of x. Okay, so even though the second and third give us the correct answer, but the third equation is better since it yields less steps. Okay, So again, in fixed point, we need to look for the equation to solve x. We need to rewrite our equation, okay, and that equation will be used to determine the root of our variable. There are instances, some equation, derived equation doesn't work. So it means you need to manipulate the equation so that we could look for the right solution, the right equation to determine the root. Okay? So if you have any question, kindly send me a course message. So see you on the next video lecture. Thank you.